Hey guys, it's Mr. Schmidt here, and in this video we're going to look at actually graphing or modeling the price elasticity of demand. And so what I want to do here is first stress something very, very important that students confuse a lot. Elasticity is not slope, okay? Elasticity is not slope. Why? Elasticity looks at percent change. Slope just looks at change. The way you calculate those are different because slope would just be new minus old. Elasticity is new minus old divided by old, okay? They're different, okay? So just make sure you don't confuse that with slope. So what we want to do now is go ahead and draw a demand curve here. And the question is, what is the elasticity of this demand curve? Well, the answer is it actually varies. So you can think of it as basically two zones along this, or to the sides of this dotted line. At the dotted line would be unit elastic. To the left of the line is elastic. And then as you go further and further down the demand curve, it becomes more inelastic. Why is this the case? Well, at higher prices, say $100, the percent change really matters, right? Like, I mean, if you take off a percentage point off $100, you are more likely to notice that and respond to it in kind than say if the price were way down here at something like $10, right? A percentage off $10 is less noticeable than the same percent off at $100. And so you're less sensitive to that price change as opposed to a change off of something like $100, which is a higher price, and therefore you notice that percent off or an increase above it a lot more. So in general, the farther up a demand curve you go, the more elastic the demand is. The farther down the demand curve you go, the more inelastic it is. And there's some point along the demand curve, somewhere down the middle, close to the middle of the demand curve, where demand is unit elastic. Now, the last thing I want to do in this video is look at two special cases of demand. One of them is this. Okay? This is called perfectly inelastic demand. Okay? What this means is that I am willing, or consumers are willing, to buy this good at any price, but they will only buy a specific quantity of that good. And so the coefficient is zero. Okay? So the price elasticity of demand coefficient is zero because quantity never changes. Remember, it's percent change in quantity demanded over percent change in price. Well, if the quantity demanded never changes, the percent change is zero. And any number, if zero divided by any number but zero, is zero. Okay? So perfectly inelastic demand is a vertical line. And the way I remember that is if you capitalize the I in inelastic, there's a vertical curve right there. Whatever. So perfectly inelastic demand is vertical. An example of this would be like life-saving medicine. You're probably willing to pay almost any price for it, but you only need a certain amount of it, right? Or maybe more like life-saving surgery, right? You don't need surgeries repeatedly over time. You just need a certain set number of surgeries, maybe 1, 2, 3, right? And so you're willing to pay almost any price for it. That's the idea of perfectly inelastic demand. The opposite of that would be this special case, which would be perfectly elastic demand. Okay, so perfectly elastic demand technically has a coefficient of infinity, but it's kind of not 100% true. But and this is not something you would need to know for the AP exam, so don't worry too much about that. But a perfectly elastic demand curve is horizontal, and the way I remember that is looking at all the horizontal lines in the capital E inelastic. Not really that many good examples of perfectly elastic demand where you will buy any quantity but only at one specific price. So I would like that there's not really many real world examples of it. But it's a thing. It's a thing. And sometimes AP questions may add that with a supply curve, and then they'll say something like, okay, now do some kind of a curve shift, right? Where, okay, let's move supply to the right. So what happens? Well, the equilibrium quantity increased, but the equilibrium price didn't change, right? It's not indeterminate. We know what happened. It just didn't change, right? It's still at that same point. So that's something they might do with this as well. So that's all for this video on modeling elasticity. Until next time, have a great day.